Hi, today we're looking at Functional Skills Maths Level 2. This is the AQA exam board. We've got the June 2022 paper and we're going to start with the non-calculator section. Question 1. Circle the ratio equal to 9:2. Okay, we've got four ratios here. Well, 9:2, we've got the bigger number on the left. So if we look at these, well, 2/9 to 1. Well, 2/9 is less than 1. So it can't be that one because we know we've got the bigger one on the left. 4.5 to 1, 4.5 to 2/9, 1 to 4.5. Well, again, we've got 1 is less than 4.5, which is the wrong way around. So it can't be that one. So it's got to be one of these two. Okay, well, if we look at them, they've both got 4.5. And 4.5, well, that's half of 9. Well, if this is half, that's a half. Well, we're going to do the same on this side. So what's half of 2? Well, actually, half of 2 is 1. So it's going to have to be that one there. Question 2. Write the number 3490200 in words. First thing I'll do is I'll put commas in. So starting from the right, we go 1, 2, 3, comma. 1, 2, 3, comma. So now we can read it nicely. So we've got 3. Well, this is going to be 3 million. So 3 million, comma. Then we've got, well, that's 490. So 490. But 490 what? Well, it's 490,000. And then what's left? Just 200. Question 3. Here is a solid made from centimetre cubes. On the centimetre square grid, draw a plan view of the solid. Okay, well, the plan view is the view, like the bird's eye view, looking straight down at this picture here. So if we look straight down at it, we would see 1, 2, 3 squares there. And note, because if you're looking down at it, you wouldn't see cubes, you'd only see the top. So it would look like 3 squares. And then we've got 1 square to the side. So that means that we'd have something like 1, 2, 3. So these would be my 1, 2, 3 like I've got there. And then we've got 1 that's next to the 3. So you don't have to put the numbers on, I've just put it so that you can see how they match up with the ones on the picture. Question 4. Work out 3.86 plus 0.013 times 5. So the first thing we need to remember is our order of operations. And that tells us that the multiplication needs to be done before the addition. Okay, so we want to do this bit first. And I'm going to ignore the decimal point. Okay, in fact, I'm going to ignore all of that. I'm just going to have 13 times 5. Okay, ignoring the decimal point and a 0 in front. So we'll say 5 times 3 is 15. And 1 times 5 is 5, plus 1 is 6. Right, but now we're going to work out where to put the decimal point. Well, we did have 1, 2, 3 decimal places here. So if we start with the point at the end, we're going to move it 1, 2, 3, put it in here. So we need to put a 0 in the gap, a 0 at the front. So we've got 0.065. Now we can add that on to the 3.86. And with this one, what I'm going to do, actually I can use a ruler on this just to make it a bit tidier. Okay, so I've got something to add the 5 to. I'm just going to put a 0 up there. So we've got 0 plus 5 is 5. 6 plus 6 is 12. 2 and carry the 1. 8 plus 0 is 8, plus the 1 is 9. Decimal point, 3 plus 0 is 3. So we've got 3.925. Question 5. Which is greater, 3 and 2/9 or 13/4? Right, you must show you're working. We want to compare these, but at the moment we've got one as a mixed number and one as an improper fraction. So we want to get them both the same. It's up to you which way you do it. I'm actually going to try and do them both as a mixed number, I think, because if I've got a different whole number, well, straight away I'll be able to tell which is greater. And if they've got the same whole number, well, then I can just compare the fraction part. So if we're looking at 13/4, really what we're saying is 13 divided by 4. So we think of our 4 times table, we've got 4, 8, 12, so that's 3 times, and 1 left over, so that's 1/4. Okay, so we're comparing 3 and 2/9. I'll put versus 3 and 1/4. But because the 3's are the same, really we're just looking at 2/9 versus 1/4. Right, so the best way is if we've got the denominators the same. We can compare that way. So what we could do is we could find the lowest common multiple, so a number that is in the 9 times table and the 4 times table. I'm going to do something a little bit different, because what I'm going to do is, it's nice if the denominator is the same, but actually if the numerator is the same, we can also do an easy comparison. And 1 is half of 2. So what we can do is, if we just multiply top and bottom by 2, so that's, I'm not multiplying the quarter by 2, I'm multiplying the top and the bottom by 2. So 1 times 2 is 2, and 4 times 2 is 8. So now we're comparing 2/9 with 2/8. Well, this means that we're splitting the shape only into 8 parts. This one we're splitting it into 9. So these are going to be smaller parts because there's fewer of them, only 8 compared to 9, but we've still got the same number. So this one is going to be the bigger one. So we can put 13/4. Okay. If you wanted to do, you could try and draw like a visual representation. So maybe if we think about splitting a shape into 9 parts, what would that look like? We'd have one there, one roughly here, something like that. So we'd just have one part shaded and another part shaded, and we can do the same over here, but split it into 8 sections. And again we've got 1, 2 parts, and you should be able to see that this section here, the 2/8, is a bit bigger than the 2/9. Now, not everyone will like this, but it's just an option. If it helps you to try and get something visual, do a little sketch, think about the question in a slightly different way, it might help. If not, you can do it purely with the numbers. Okay, question 6. Toy cars. Max has made a straight racetrack for his toy cars on a floor. The grid represents the floor. So we've got point A here, point B down here. Okay. And they tell us the straight track starts at A, 110, so that's up here, and finishes at B, 13.2, which is down here. There is a flag at the halfway point of the track. Work out the coordinates of the flag. Right. So there's a couple of different ways of doing this. First I'm going to draw the track. So I've got my ruler. Nice straight line. So you could think of this, if the sort of the GCSE way would be to say, well, let's look at my X coordinates, find out what half of that is, do the same with my Y coordinates, and then that will give me where the centre is. But I'm thinking, well, maybe we can do it a bit easier than that. And we can just say, well, how long is this line? Now, it's going to be slightly different. So I think it might be easier if you did it with the real exam paper. And I say that because when you print out the sample papers, it always scales them down a little bit. But we can still do it on here. So I'm getting that as 14.4 centimetres, I think. So if we want to know what half of that is, well, we want 2 into 14.4. Let's bring that down. 2 into 1 doesn't go. 2 into 14, 2, 4, 6, 8, 10, 12, 14. That's 7 times. Decimal point. 2 into 4, 2, 4. That's twice. So halfway would be 7.2 centimetres. So get my ruler, line it up there. 7.2 is going to be right there. Okay, so we just need to read off the coordinates from that. Well, it's going to be 7 down here and 6 on the Y. Okay, 6B. Max wants to compare the performance of 2 cars, P and Q. Each car does 4 timed races on the track. For car P, the mean equals 9.3 seconds and the range equals 3.8 seconds. The table shows the results for car Q. So we've got race 1, race 2, race 3, race 4, and this is our time in seconds. Compare the average time and consistency of the 2 cars. You must show your working. Okay, so average time. Well, the average time is going to be the total of all 4 times divided by how many? Or the frequency. Right, so we're going to add these up. It's 10.15, 8.35, 7.8 and 12.1. And because they've not got the same number of decimal places, I'm going to fill these in, these blanks, with zeros. 5 plus 5 is 10, plus 0 is still 10. Okay, well, I can add these in any order, so I'm going to do 8 plus 1 is 10, plus 3 is 13, plus 1 is 14. Bring the decimal point down. 8 plus 2 is 10, plus 7 is 17, plus 0 is still 17, plus the 1 is 18, and 1 plus 1 plus 1 is 3. Okay, so we've got 38.40 divided by how many? 1, 2, 3, 4. Right, so with this one, I'm going to do it using the bus stop method. Well, how many times is 4 going to 3? 3 is smaller than 4, so it doesn't go at all. So what about 4 into 38? So 4, 8, 12, 16, 20, 24, 28, 32, 36, that's 9 times. And 37, 38, so that's 2 remainder. So put the decimal point up there. How many times is 4 going to 24? 4, 8, 12, 16, 20, 24. So that's 6 times. So we've got a mean of 9.6. Well, it says compare the average time. I mean, we for us, the mean is the average we're using, okay? We could have worked out the median, I suppose, if we wanted to, but we've gone with the mean. Compare the average time and consistency of the 2 cars. So for the average time, we can say, oh, they've worked out the mean up there, so we're being consistent. The mean time of car P is quicker than the mean time of car Q. And we can show that by saying 9.3 versus 9.6 seconds. Now for the consistency is looking at sort of how reliable it is, or what's the difference between the fastest and the slowest time. So the fastest time for car Q is 7.8, it's the lowest number, and the slowest one, the biggest number, is a 12.1. So the range, which is what we're using to work out the consistency, is the biggest minus the smallest. Okay, so we need to do our 12.1 minus 7.8. So 1 minus 8, so we can't do because 8 is bigger than 1, so make that 1, pass that over, so we've got 11 minus 8, which is 3. 1 minus 7 we can't do, so we could make that a 0 and pass that over. It's the same as just saying 11 minus 7, which is 4. So we've got a range of 4.3. So this was a range of 3.8, so we can say car P is more consistent. So what we're saying is the change between the fastest and slowest time is smaller, more consistent than for car Q. And just to show that, we can say because 3.8 is less than 4.3. Okay, in fact we could do that instead of verses up there, we can have that as a less than sign. 6C. Max needs to buy batteries for the cars. There are 2 packs to choose from. Pack A costs £5.60. You've got 8 batteries and each battery lasts 3.5 hours. Or pack B costs £6.30, 10 batteries. Each battery lasts 3 hours. Which pack is better value for money, A or B? You must show you're working. Right, well, we've got lots of things that are different. The price is different, the number of batteries are different, the length of time the batteries last is different. So let's start off by saying, well, how long would each pack last in total? So what we can say, if we start off with pack A, we can think, well, each pack lasts 3.5 hours. So we've got 8. Well, 8 times 3, or 3 times 8, 8, 16, 24. And then we've got half an hour. So half of 8 is 4. Okay, so we're saying 3.5, 8. So we're saying 8, 16, 24 plus 4. Plus 4 is 8, 20. So 28 hours is how long pack A lasts. Okay, and then we can say for pack B, well, we've got 10 batteries lasting 3 hours each. 10 times 3, that's going to be 30 hours. That's a bit more simple, that one. Okay, so now we can start to think about the money, or we can think how much are we paying per hour. So what we'd like to say is £5.60 divided by 28 hours. That'll tell us the cost per hour. But instead of thinking pounds, because then we've got decimals in there, think in terms of pence. So this is the same as 560 pence, or 560p. Okay, so we can say 560 divided by 28. Okay. Now, what might help with this one, we can write it as a bus stop method. And we can say, well, does 28 go into 5? No. What about 28 into 56? Well, let's think about that. Well, what about if we just had 2 28s? 8 plus 8 is 16. 2 plus 2 is 4, plus 1 is 5. Ah, perfect. So 28 goes into 56 twice. 28 goes into 0, 0 times. So what this is telling us is that it costs 20p per hour. Right. Now we're going to do something similar for pack B. Well, for pack B, £6.30, well, we can say this is the same as 630p. And we'll do something different. Well, no, not too different, to be honest. We want to say 630 divided by 30. Right. Well, we've got 0 on the end of both, so we can cancel those off. So basically what we've got is 63 divided by 3. 3 goes into 6. 3 is 6. That's twice. And 3 goes into 3 once. So we've got 21p per hour. So which pack is better value for money, A or B? Well, it's going to be A, because 20p is less than 21p. And that's the end of the non-calculator section. Now for the calculator section. Question 1. Here are 4 numbers. Work out the median. Right. Well, the first thing we want to do to work out the median is to put our numbers in order from smallest to largest, or largest to smallest. Well, they've already done that for us. They're getting bigger. Then we look at the smallest and largest, cross them out. We're left with 2 numbers. If it was just one number left, we'd take the middle one. Because we've got 2, we need to add them together and divide by 2. So 11 plus 13 gives us 24. Then we want to divide that by 2, which gives us 12. Or you could say, well, what number's halfway between 11 and 13? Well, it's 12. Question 2. Write these numbers in order, starting with the smallest. Well, the negative numbers are going to be the smaller ones, these here, and the more negative it is, the smaller it is. Or think in terms of temperature, which would be the coldest. Well, the most negative is minus 20. Then we've got minus 16. Then we've got minus 2. Then minus 1. Then we just do, well, what's the smallest? 4, and then 7. Okay. Question 3. Here is a diagram made of 3 straight lines. Work out the size of angle X. Alright, so we can do this in a few ways. Now, I don't want to assume too much, but one of the things that we should know is that the angle's in a straight line. Here's a straight line. So this straight line should add up to 180 degrees. So if we want to find this angle in here, well, it should be 180 minus the 59. So this is 121 degrees. Now we've got another straight line here. So this angle is going to be 180 minus 121 degrees. And if we do that, we get back to 59. So it is the same because they're opposite, but we don't necessarily need to know that fact to say we can work it out just based on the fact that the total number of degrees in a straight line is 180. So we've got this angle is 59 degrees. This is 76 degrees. The other fact we need to know is that the total angles in a triangle add up to 180. So if we add these two together, so 59 plus 76, we get 135 degrees. So X must be the difference between 180 and 135 degrees, which gives us 45 degrees. And we can put that down there. Okay. Question 4. Work out the percentage increase from 250 to 330. Well, if we want the percentage increase, the best way to do it is to first work out the actual increase. It's not the only way to do it, but I think it's probably the easiest way to understand. So we'll do 330 minus 250. So it's increased by 80. Now, if we want to know the percentage increase, well, we're saying 80 out of 250, because that's what we started with. And then to make it a percentage, we're going to multiply it by 100. So 80 out of 250 times 100, and we get 32%. Okay, question 5. The radius of a semicircle is 5 centimetres. Work out the perimeter of the semicircle. Right, so we're going to need a couple of extra measurements where we want this full length here. Well, if that's 5 centimetres, the radius is from the centre to the outside, so this is going to be another 5 centimetres. We just need to know what this distance is around the outside. Well, the circumference of a circle is equal to 2 pi r, which means 2 times, when you've got a number times a letter or a symbol next to it, means multiply. Pi, we can use 3.14. And for r, well, r is 5. So with our calculator, 2 times 3.14 times 5 is 31.4. That's the circumference. But we don't want the full circumference. We only want half of a circle. So we want 31.4 divided by 2, which is 15.7. So this distance around the outside, around here, is 15.7 centimetres. So that means that the perimeter is 15.7 plus 1 5 and plus another 5, which gives us 25.7 centimetres. Question 6. Family. Ruth is on holiday. The hotel where Ruth is staying has a total of 720 rooms, 4 different types of room. The table shows information about the rooms. Okay. Let's see if we can get a whole question on here. Yeah. Okay, so we've got a single room. The fraction of the total rooms is 11 out of 40. A double room, 7 out of 16, or 7/16 of the total rooms are double rooms. We don't know the fraction for family rooms, and luxury rooms, 1/5 of all the rooms are luxury rooms. Show that more than 8% of the rooms are family rooms. Right, well, what we want to do really is work out this missing value here first of all. We can, one way to do it is to turn these all into decimals, but actually instead I'm going to do it slightly differently and just say, well, if we want to know how many rooms are single, well, we would just do 11 over 40 times 720. And that gives us 198 rooms. So we can call this number of rooms. Okay, so we can do a similar thing here. 7/16 of 720 is 315 rooms. We can't do the family rooms yet, but the luxury rooms, 1/5 of 720 is 144 rooms. So how many rooms do we get from these three types? Well, 144 plus 315 plus 198 is 657. So the family rooms here must be the total 720 minus these 657 rooms, which gives us 63 rooms. Okay, now they said show that more than 8% of the rooms are family rooms. Well, 8% would be 8 out of 100 times 720. And that would be 57.6 rooms. So we can say 63 is greater than 57.6. There's other ways of doing it, but I think this is probably the nicest way. (6b). During the holiday, each guest visits either a castle, a zoo, or a museum. The probability that a guest, chosen at random, visits the castle is 0.55. And they visit the zoo is twice the probability that they visit the museum. 2 guests are chosen at random. Work out the probability that both guests visit the museum. Right, okay. So let's think. We're going to have, let's draw a little table. We're going to have guest 1 and guest 2. And they can visit a castle, a zoo, or a museum. And I say the probability that a guest visits a castle is 0.55. And that's going to be the same for each guest. The probability they visit the zoo is twice the probability they visit the museum. Well, these two probabilities in total, well, if we think about all of the probabilities, they need to add up to 1 or 1.00. So these two in here must be the difference between 0.55 and 1. So if we do 1 minus 0.55, we get that these must add up to 0.45. Okay, so if we do, I'm going to do a little ratio table now, and we're going to have zoo, museum, and total. So we're only thinking about the zoo and the museum here. Okay, so we're saying the probability a guest visits the zoo is twice the probability they visit the museum. So that's saying every time they visit the museum once, they go to the zoo twice. And if that's all they did, there would be 3 visits in total. Okay, now we need this total to actually be our 0.45. Or to maybe make it a bit easier, let's turn that into percentage. And let's say that's 45%. Okay, so we need our total to be 45%. Well, how can you get from 3 to 45? Well, if we work backwards, 45 divided by 3 is 15. So it means we multiply by 15 to get from 3 to 45. So let's do the same with these. 1 times 15 is just 15. 2 times 15 is 30. Okay, so that's, remember these are all percentages. So we want to turn these back into decimals now to put them in our table. Well, you multiply by 100 to get the percentage. To get to a decimal, you need to divide that by 100. So we get 0.3 for the zoo, and 15 divided by 100, 0.15. And we can check that, because if we do 0.55 plus 0.3 plus 0.15, it adds up to 1. Right, excellent. So what that means is it's going to be the same for guest 2. Now we want to work out the probability that both guests visit the museum. So that's going to be 0.15 times another 0.15, because those are the two things that we want. So 0.15 times 0.15. We get 0.0225. Okay, and they haven't told us how they want it, percentage, decimal. They gave their answers in decimal, so I'm just going to leave it like that. So this is quite a tricky one for probability, okay, but I think it helps if you start to lay things out nice and tidily and then do something with the ratios. But for me, percentages are easiest, so we kind of get away from the decimals for a little bit. Okay, 6C. Ruth saves £3,000 to pay for another holiday in 4 years' time. She sees adverts for 2 banks. Bank A pays 2.1% compound interest per year. Bank B pays 1.6% simple interest per year. Ruth says the total interest for 4 years will be at least £65 greater if I invest the £3,000 in Bank A. Show that she is correct. Right, okay, so with Bank A, the way it's going to work, when it's compound interest, you can use a formula. And what you need is the amount, so in this case it'd be £3,000 times, and it's going to be 1 plus, now it's the interest rate divided by 100, because you're trying to get it in terms of you want it as a decimal, and then it's to the power, the number of years, so it'd be to the power 4. So what that's going to look like is £3,000 times, now this is where we do it, the interest rate, so 2.1 divided by 100 is 0.021. That's the interest rate. We don't want just the interest rate, we want to add 1 to it, because we want to find out what the amount's going to be worth, not just the interest amount. So we need to add on the 1. So 1.021. 1.021. So this would tell us how much the total amount is worth after 1 year. If we multiply it by another 1.021, that would tell us what it's worth after 2 years. We've got 4 years. So 3, 4. Okay. So let's move this up so we can see the calculator. So 3,000 times 1.021, that's 1 year, 2 years, 3 years, 4 years. And it's worth 3,260 point, where are we, 2 decimal places because it's money, 0.4, but this is bigger than a 5, so it's going to be 0.5. Okay, now they're talking about the total interest, so they actually don't want the original amount that's invested, so we want the 3,260.05 and then minus that £3,000. So if we subtract 3,000, we get £260 and 5p. Right, now at least greater if I invest the 3,000 in Bank A. Right, so for Bank B, we want the simple interest. Well, to work out the simple interest, that means the interest amount is going to be the same every year. So we just want 1.6% or 1.6 over 100 times the 3,000. And then because it's 4 years, we can just multiply it by 4. So again, we're doing this divided by 100 to get the interest rate as a decimal. Multiply it by 3,000. So we're going to get £48 a year. Multiply it by 4. That's £192 in total. Okay, so well, let's work out how much more they get with Bank A. So £260 and 5p minus 192. That gives us £68 and 5p, which is greater than £65. So is she correct? Or it says show that she's correct. Well, we have done. Question 7, skateboarding. Jess is organising a skateboarding competition. Ooh, excuse me. 7a. Here is a diagram of a skateboarding ramp. So we've got the base here, we've got the width. Here's a scale drawing of the front elevation of the skateboarding ramp. Okay, so by the front elevation, looks like they're talking like this, because if we look at the picture, that's what it looks like. Okay, I would have called that the side elevation, but that's fine. That's what they're calling it. It's drawn on centimetre square paper, and we've got the scale here. The 2 centimetres represents 0.3 metres, and they're saying that each of these is 1 centimetre. Now remember, if you printed this off, as I have here, I'll show you 1 square. Oh no, it is exactly 1 centimetre. That's fine. Sometimes when they get printed off, it doesn't match exactly, but it appears to be the case here. So that's okay. Right, so let's see what the actual question is. Well, it tells us, here is the formula to calculate the volume of the ramp. And we're told the volume equals the length of the base cubed times 1.7 divided by 1.2. The ramp is made of concrete. The density of concrete is 2,400 kilograms per cubic metre. Work out the mass of the ramp. Okay, right, well, they're talking about the length of the base here. So I think the first thing I'm going to do is go back to my diagram and try and work out the length of this base. Well, let's count the squares to start with. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we've got 14 squares. Well, 14 squares, or you can call that centimetres. And we're told that 2 centimetres represents 0.3 metres. So what we can say, well, that means that 1 centimetre represents, so 1 is half of 2, so if we do 0.3 divided by 2, so that means 1 centimetre represents 0.15 metres. So 14 centimetres represents, so we need to do 0.15 times 14, so represents 2.1 metres. Okay, so that's the first bit. So the length of our base, we're saying, is 2.1 metres. Okay. Now, hopefully we won't need to go back to our diagram. Now, what's helpful here is to understand, they're talking about the density of concrete. And it might help to draw a triangle. Now, you might have seen this when we're working with speed, but you can also do it with density. Now, when we're working with density, it's sort of how much of something you've got in a small space. And the way that we work that out is that we say, well, the mass is equal to the volume times the density. So the mass or the weight depends on how big it is, and then how much per bit of space you've got. Okay, so we know the density because we're told that this is 2,400, and we've got a formula for working out the volume. So if we want to work out the mass, we can say the mass is equal to the volume times the density. Right, so say we've got the density, we just need to work out the volume now. So the volume is equal to the length of the base, 2.1, and it's cubed, so that means times itself and times itself again, so 3 times. Not 3 times 2.1, but 2.1 times 2.1 times 2.1. Then multiply it by 1.7 and divide that by 12. So if we do all of this, we get 2.1 times 2.1 times 2.1 times 1.7 divided by 12. And you get 1.311975. I'll write all the digits down for now. Okay. Right. Now, some people might be saying, well, this is order of operations. BIDMAS, you should do division before you do the multiplication. Well, actually, with something like this, the order doesn't matter, and I'm going to show that to you. So if we did the division first, and we said 1.7 divided by 12, okay, so we've done this bit, and then multiply by 2.1 times 2.1 times 2.1, you get the same answer. Very slightly different because you've got a rounding difference at the end, okay, but certainly to, what's that, 4 decimal places, it's going to be the same. Okay, so it's fine if you've done it the other way. We want the mass, so the mass is this volume, I said 1.311975, times the density, which they've said is 2,400. Multiply those together, times 2,400. And then let's round it to 2 decimal places. So we've got 3,148. 2 decimal places would be 7.3, but the 7's more than a 5, so we're going to round that up to 7.4. And the mass is going to be in kilograms, because it's kilograms per cubic metre. So we can just put that in here. (7b). 160 skateboarders enter the competition. The skateboarders are adults or children. Each school skateboarder does the Yogi Run or the Zulu Run. 40% of the skateboarders do the Zulu Run. 18 of the children do the Yogi Run. 20 more adults do the Yogi Run than the Zulu Run. One skateboarder is chosen at random. Work out the probability that the skateboarder is a child. You may use the table to help you. And I think this table is going to help us a lot. So what we're going to do is we're going to populate this table, and then we can work out a probability from here. So what values can we put in? Well, they're telling us 40% of the skateboarders do the Zulu Run. Okay, well, that means it's going to be this box here, and it's 40%. So 40% is going to be 40 out of 100 of the total, which is 160. So 40 out of 100 times 160. We've got 64 in total did the Zulu Run. Then we've got 18 of the children do the Yogi Run. Oh, well, they've already given us that bit there. But what we can work out, if we know that there's a total of 160, 64 did the Zulu Run, well, the ones that did the Yogi Run must be 160 minus the 64, which gives us 96. And so if we want to work out how many adults did the Yogi Run, Well, this one is going to be the difference. If it's 96 in total, 18 did the yogi, the rest must be adults. So that's 78. Okay, now what else can we use? 20 more adults do the yogi run than the Zulu run. So 20 more do a yogi than Zulu. So this must be 78 minus 20. So it's 20 fewer, which gives us 58. Well, if the total's 64, 58 are adults, the children must be 64 minus the 58, which gives us 6. Now we just need our totals here. So 18 plus 6 is 24. 78 plus 58 is 136. And if we want to check, 136 plus 24 should give us 160, and it does. Right, so we've done the table, but we've got to make sure we don't just stop there, because there is an extra bit to the question. One skateboarder is chosen at random. Work out the probability that the skateboarder is a child. Well, the total number of children is 24. So we want 24 out of 160, which we could just leave it at that, to be honest. That's a probability. But if we do it as a decimal, you get 0.15. So either of those answers would be fine, or 15%, all saying the same thing. Okay, question 8, walking marathon. Yannick is walking a marathon to raise money for charity. The marathon is 26.2 miles long. Yannick starts at 9:30 a.m, walks a constant speed of 4 miles per hour, and takes 3 breaks that are 15 minutes each. Will Yannick finish the marathon before 5 p.m? You must show your working. Okay, right. Well, I'm going to start off by saying, well, we've got 3 breaks that are 15 minutes each. So let's work out what the total of that is. So it's 3 times 15. That's a total of 45 minutes. Okay. So we can say, well, how much time have they got in total? Yeah, so if we're starting at 9:30, well, we can move forwards. What I'm going to do is say, well, we can go forwards to, he's going to finish at 5 p.m. So we can go 10:30 would be 1 hour, 11:30, 12:30, 1:30, 2:30, 3:30, 4:30. So that's 7 hours to 4:30. 7 hours to 4:30. And then to get from 4:30 to 5 p.m, that's another 30 minutes. Okay, so 7 hours and 30 minutes is how much time we've got altogether. Okay, so we can say, right, maybe let's turn it into minutes, shall we? So we can say that that's going to be 7 times 60, because there's 60 minutes in an hour. And add on the 30. So 7 times 60 plus 30 means in total he's got 450 minutes. But we know he's going to have 45 minutes of breaks. So if we take off the 45, we've got 405 minutes of walking. Okay. Right. If it's 26.2 miles long and he's doing 4 miles per hour, how many 4 miles will fit into 26.2. So if we say 26.2 divided by 4, we're saying we need 6.55 hours. That's how long it's going to take. Well, actually, we're trying to compare it. We've got the time in minutes down here. So if we want to compare these, we've got minutes, we've got hours. Let's turn, well, we can do either. We can turn this into minutes, or we can turn this into hours. I'm going to turn this into minutes, I think. So 6.55 hours. Multiply that by 60, because there's 60 minutes in an hour. And we get 393 minutes. Okay, so it's going to take him 393 minutes. He's got 405 minutes to do it. So we can say 393 is less than 405. So, yes, he'll finish before 5 p.m. There's different ways of doing it. I quite like this way. You just be careful that this, when you've got something like 6.55 hours, it's not saying 6 hours 55 minutes. You've got to be careful if you're using, whether you're in decimals or hours and minutes. As long as you're consistent, you'll be okay. 8b. This year, 30,000 people walked the marathon. The table shows the time it took the walkers to complete the marathon. So 5,001, let's put the commas in, make it easier. So 5,001 people took between 5 and 7 hours, 14,516 took between 7 and 9 hours, and so on. Right. Last year, the mean time was 9.2 hours. The marathon organiser says, this year the mean time was lower by more than half an hour. Is the organiser correct? You must show you're working. So we've got to work out the mean. And because we've got these ranges, to work out the mean, we need to use some midpoints. And that means we don't know exactly where within these ranges or what times people took, so we're going to assume halfway between. So you can add the two ends of the ranges together and divide by 2, or you can just look at it and say, well, what's halfway between 5 and 7? Well, it's going to be 6. Halfway between 7 and 9, it's 8. Halfway between 9 and 11 is 10. And halfway between 11 and 13, that's 12. But say if you can't see that, for example, the last one, you do 11 plus 13, divided by 2, and you still get the 12. So that's the midpoint. Now we've got the midpoint, we don't care about the ranges anymore. We want to know, well, the mean is the total divided by the frequency. Well, what's the total? And the total is the total hours that we're interested in. Okay, and to work out the total hours, we need to multiply the number of people by the hours they took. Because remember, this 6 means 6 hours. So 5,001 times 6, we get 30,006. So we'll just put frequency times midpoint. Okay. And then for the next one, 14,516 times 8. So again, we're multiplying these all together. We get 116,128. This one I'll do without a calculator. We can just add a 0 on the end because it's times 10. 2018 times 12. 24,216. So how many hours in total? Well, if we add them all up. And you want to be really careful with this because when they're big numbers, it's so easy to mistype on the calculator. 255,000 hours. So for the mean, 255,000 divided by the frequency. Well, the frequency is the number of people, and we were told that that's 30,000. Okay. So 255,000 divided by 30,000 gives us 8.5 hours. Okay, this year, the mean time was lower by more than half an hour. Well, 8.5 plus half an hour would take it up to 9 hours. Okay, so even if you add on half an hour, we've still got that 9.2 is greater than 9, so yes, they're correct. If you wanted to do it slightly differently, and I think maybe I prefer it this alternative way, we can look at the difference. So we can say, I'll just do it down here. We can say 9.2 minus 8.5 is 0.7, and then we can say 0.7 is greater than 0.5. So, correct. So either way, although I did this way first, I think actually this is maybe a little bit nicer, but it's fine, either of them. Okay, 8C. The 30,000 people in the marathon were in the ratio adults to children is 11:1. Each adult paid an entry fee of £38. Children walked for free. The charity's target was to raise £1 million from entry fees. Did the charity meet its target? You must show you're working. Right, so we've got a ratio question here. And we know that because we've got a ratio given to us and it says ratio. And the ratio we've got is adults, children, and we're going to have a total column as well. And the ratio is 11 adults for 1 child. So if we only had 11 adults and 1 child, that would be 12 in total. But actually, we had 30,000 in total. So how many times bigger is that? So let's think 30,000 divided by 12. So that means we're multiplying this by 2,500. So for children, that's going to be easy. It's going to be 2,500 children. For the adults, we're going to need to multiply 11 by 2,500. Which gives us 27,500 adults. Right, so you've got 27,500 adults, each of them paying £38. So in total, they are going to be getting £1,045,000. Well, that is greater than 1 million. So did the charity meet its target? Yes. Question 9. Garden pool. Chen has a pool in his garden. Chen's pool is cylindrical, or in the shape of the cylinder, you could see. We've got a picture of it here. The diameter of the pool is 2.3 metres, so the distance from one side to the other going through the centre. Chen wants the depth of the water to be 1.6 metres. The hose pipe fills the pool at a rate of 50 litres every 4 minutes. 1,000 litres equals 1 cubic metre. How many minutes will it take for the pool to go from empty to the required depth? Right, so we got to know how much water is in there to start with when it's full. So to work that out, if you think we've got our cylinder, and I'm just going to sort of draw the base there. Okay, so you can imagine that's the bottom and it's full up, and we'd have this dotted line going around like that. So if we want to work out the volume of that, well, you know the volume of a cuboid is the length times the width times the height. Volume of a cylinder is the area times the height. and the area is pi r squared. Right, where pi is 3.14, pi r, so that means times r, or r squared. R is the radius, which is r, is half the diameter. So radius is 2.3 divided by 2, which is 1.15 meters. So that means the area is 3.14 times 1.15. Because it's squared, we've got to multiply it by it again. So 3.14 times 1.15 times 1.15. And we get 4.15265. That's meters squared because it's area. So the volume is 4.15265 times the height, which is 1.6. Which is 6.64424 meters, because its volume is now meters cubed. Right. Now, we're told about how quickly this fills up, but we're told in terms of litres. So we've got to go from volume, or cubic meters, to litres, which is more sort of capacity. And there's 1,000 litres for every metre, so we've got to multiply this by 1,000. Which gives us 6,644.24 litres. Right. We know it fills at a rate of 50 litres every 4 minutes. Well, actually, I'm going to say, well, that's great that it's every 4 minutes, but what about if we just say, what is it every 1 minute? So 50 divided by 4 means it's 12.5 litres, and I'm just going to, so we don't get that mixed up, per minute. So if we want to know how many minutes it's going to take, we're going to take the total 6,644.24 litres, divide that by 12.5 litres, because that's how many are going in every minute. And let's see what we get. 6644.24 divided by 12.5, and we get 531. I'll do it 2 decimal places, 5.3, but that's bigger than a 5, so we make it 5.4 minutes. And that's our answer. They haven't asked us to do it in hours and minutes, they've just said minutes. In fact, even on the answer line down here, it's in minutes. So we can put that down there. And finally, 9B. Chen needs to buy 3 gallons of cleaning chemical to put in the pool. He sees this advert online. Pool cleaning chemical, £8.49 per 1 litre bottle. Buy 4 or more bottles and get 1/6 of the total cost. Chen says, it will cost less than £100 to buy the bottles of chemical I need. Is Chen correct? You must show you're working. 1 gallon equals 4.546 litres. Right, he needs 3 gallons, he says. So everything else is in litres, so let's change the gallons to litres. So 3 times, that's 1 gallon. So we're going to want 3 times 4.546. Make that a bit tidier. 13.638 litres. Okay, £8.49 per 1 litre bottle. Well, I'm assuming that we can't buy part of a litre, so we're going to need 14 bottles. Okay, so that's going to be 14 times £8.49. Which is £118.86. But then they do say buy 4 or more bottles, and we certainly are, we're buying a lot more than 4, you get 1/6 off the total cost. So let's work out what 1/6 is, and then we'll subtract it. Okay, so we've already got that there, multiply it by 1/6, and we get £19.81. So then we want to say £118.86 minus £19.81. We get £99.05, which is less than £100. So yes, Chen is correct. Now, just to show you, you could do this with a little bit of a shortcut. We worked out 1/6 and then took it off. You could have just said, well, if we're going to take 1/6 off, that means I'm going to be left with 5/6. So we can just work out 5/6 of £118.86. Which, what did I do? 5/6 times £118.86, and that takes us straight to the answer of £99.05. Okay, this is a bit quicker and nicer, and certainly if you're thinking of moving on to GCSE afterwards, this is a good way to do it. This is maybe easy to understand, and you might be less likely to make a mistake, but either way it's going to be fine. And that's the end of the paper. So I hope you enjoyed it or found it helpful. Please like the video, subscribe to the channel, turn your notifications on, and look forward to seeing you soon. Thank you.